Today we'll be looking at jumps and a little bit of labels here and there, but mainly we'll be focusing on jumps in assembly. So let me go ahead as usual and create a new file. So I'll name it jump.s. Then, as usual, let us declare our usual section where we'll be writing our source code, which is the text section. Again, define our starting point, global start. Then we start at this starting point. So what are jumps? So maybe using an illustration, I might be able to explain to you what it entails initially. So you can see this as maybe the instruction set where we are. So maybe we have some instructions here. So you can see this as maybe the memory layout. So you can, maybe this is the memory layout of how our code is being executed. So mem layout. So if we have, maybe we have what a jump enables us to do is that we can jump literally to jump from one part of our source code to the other. So for example, we have code here. So let's say this is our starting point. We can tell the computer to jump to, when it reaches somewhere here, to jump at the top. So initially, jumps are just named memory locations where you instruct the assembler to go back and forth, or to jump back and forth to execute the line at the place that the jump has landed. So let us see it in code. So we'll go ahead and maybe let us do something like addition, simple addition. So EAX, let us load the value 12. So 12. And then move to EBX, maybe something like 13. So after that, let us add EAX to EBX. Maybe that's what we want to operate, but let me show you how now you can actually jump from one part of the code to another. So, and for that to happen, we have to use labels. So for example, this is a label. So you have to define your own label where you want it to jump, which the label will be the named location where the assembler will jump onto. So I can maybe I will name it subtraction. Like that, you start by the name followed by a full colon. Then here you can maybe move your values. Again, we can use the same registers. So 20, then move into EBX the value, let's say something like 10. Then over here, let us subtract. So we can subtract EAX to EBX. Like that. Then over here, let us do our usual exit. So 1, move to EBX 0 int 80h to 80h. So when the assembler or the assembly language runs the program from top to bottom, but when it encounters a jump, it can alter the flow of the program to go to where it has been instructed to jump. So for example, we can start by jumping here. So by jumping, you just use the JMP keyword followed by the name of the label, which was subtraction over here. So we'll go ahead, subtraction. So when the assembler runs, it will come to this jump instruction. Omit these instructions and go straight to the jump, finish it. After finishing it, now it will go now sequentially now to the program exit. It won't go back up. It will go just the way down because it executes code from top to bottom. So when it encounters this jump instruction, it says, oh, where are we jumping? To the subtraction. Then immediately it jumps and it ignores these statements over here. So let us save our program. Then let me try and compile it. So elf 32 load, we want our source file, then generate our object file, which will name jump.o. Then let's go ahead and just try to link it. So elf i386, just that way, then followed by the name of the object file, followed by a dash o, then like that. Now executable. So what's not going on? So LD cannot find jump. So jump, it's not jump, it's jump, like that. Then let us try and debug it using the debugger. So gdb, we named it jump. Again, we'll use our normal layout, ASM, make a breakpoint where at start, then run our program. So not run. So we'll go and step into each instruction. So as you can see, let us see how we can run. So we can go and maybe step into each individual instruction. So as you can see, it encounters the jump first, ignores all of these instructions over here, including the add, goes to the subtraction directly and execute what's below the label. So we can go and step I. Now it is in the subtraction, step I. So now we can check info registers where EAX. So you can see now it has done the subtraction part instead of the addition, because the first command was to jump to the subtraction. So it has ignored the addition part, gone to the subtraction, did the arithmetic, and then stored the value into the register EAX, which was 20 minus 10, if I'm not wrong, which is 10. So let us go ahead and let us run it again, maybe for you to see what is going on. Yeah. So layout ASM, where we are breaking at the start. Then go ahead and run. So you can see it starts at jump. So when we execute this command, it will go straight to this location, which is the subtraction part over here. So step I, so you can see it has jumped these instructions over here, went straight into the subtraction, and when you step I, now it will go ahead and execute our subtraction operation. So let's go back to the lab to our source code, and maybe we can do an overview. So jumps, you can see them, that is an instruction that tells the assembler to go to some random or some memory location which is named. So, and the naming comes from this label, so that it can execute some code over there. So an equivalent of jump, if I'm not wrong, is the go-to statement inside the C programming language. I don't know if Python has such structure, but I can remember from my college days, we had go-to statements in C. So this is similar to that. So this is a go-to statement. So whenever the assembler encounters a jump, it goes immediately to where you have ordered it to jump. So, and it jumps into memory using now these labels. The following label will now guide the assembler where to jump to and from. So maybe we can, after doing the subtraction, now you can, maybe here you can also jump again now to the top. So let us try it. After doing the subtraction, we jump using the GMP. We can jump up again. So in order to jump, we have to maybe name this or give this a label. So I can say add, like that. So this will hold our add. Then after that, we want it to jump where? To add. Then instead of because it will go back and forth, here we can maybe write our system exit after it has subtracted. Now back to the add, and then we over here try to, okay, or we can try it that way. There is no problem. Let us experiment. So we can, let's see if we can jump back up again. So let us compile this again. Then let me run the debugger, layout, ASM, break at start, run. So immediately we start at the jump point, and we'll just step one instruction. So go to the subtraction. So step I. Now we go to the instruction step I. Then we can see the results in the register. So info registers EAX. You can see it has done our subtraction successfully. Now we have now the jump instruction again. So it will jump again to this location over here. So step I. So we go back at the top. Then we step I again. We step I again. Now we are on the add, step I. Then we can check into the registers if it has register EAX. So you can see we have 25 because I think we have put 13 and 12 or something like that. So it's 25. Then let us try, and so it, after doing that, it will go back to the subtraction now, because you remember that the instruction setup of assemblies top to bottom. So it will go ahead, do the subtraction, then jump again. So we'll be in an infinite loop of sorts. So let me you can see, so let me exit. So it will go here, then encounter a jump, go back on top like that. Then it see this again, go to the, so it will be a back and forth instruction. But I hope you have understood the basics, or the basics of jumps and labels. So label, you can see like some named memory location on. Maybe you can group, so you can say maybe it's a grouping of some instruction. You can group instructions together using one particular name. But the main takeaway is this jump instruction. So this tells the assembler, the assembly language, to jump to somewhere you have instructed it to go. So jump to subtraction, jump to addition. So I might urge you to do some exercise using these jumps and see them in action. But if you have any question, you can feel free to ask me, and I will be delighted to answer you. So thank you for your time, and let me see you on the next one.